Hello and welcome to today's lesson on graphing motion. So we can investigate the relationship between distance and time, these two things required for speed, in many ways. A lot of times what we do in this class is we use mathematical calculations and equations. We use these a lot. But you can also plot them on a graph. And so we've talked a little bit about graphing. And if you remember, I gave you a little saying that it's called dry mix. And this is to plot our variables on a graph. We're going to talk about this in a second. And when you graph distance and time, we put distance on the vertical axis and we put time on the horizontal axis. So since distance is on your vertical or your y-axis, it represents, we're going to undo that, make a better line there. Since distance is on your y-axis, it represents the dependent variable. Remember, dry mix, the D is dependent, R is responding. So dependent, also called responding variable, is on the y-axis. There's the dry part. It represents the dependent variable because your distance depends upon the amount of time the object is moving. The distance depends on the time it moves. Time is on the x-axis, the horizontal axis or the x-axis, which makes it the independent variable. So if we go back to our dry mix, the mix side of things, M stands for manipulated, which is another word for independent. It's the one that we manipulate. So manipulated. It's the manipulated variable. It is also called the independent. Independent. And goes on the x-axis. So dry mix will help you remember those. So time. Time will pass. Whether the object is moving or not, time is going to move, and that's why it is our independent variable there. So the slope, when we make a graph, we can find the slope of this line. And so if we have a graph here with distance on the y-axis and time on the x-axis. So remember, slope is equal to rise over run as far as data goes. And so if we're determining the slope of this line, we're looking at how far up it goes compared to how far over. So rise, it starts at 6 and ends at 12. So rise is going to be equal to 12 minus 6 is our rise, since it's going to go up 6 places. So each one is 2. So 1, 2, 3, 4, 5, 6. And the run is horizontal, so it went from 1 to 4. So final minus is going to be 4 minus 1. So 12 minus 6 is 6. 4 minus 1 is 3. My slope is 2. Now if I put units on this, 12 minus 6, these are both in meters. So this is going to be 6 meters over 3 times measured in seconds. So I'm going to have 2 meters per second. That is my slope there. If we go here, sometimes graphs make data really easy because you can visually compare what's happening. So we compare the red line with the blue line. We can look at which one has the larger slope. So I have a red line versus a blue line. Red line and blue line here. So the red line goes up this way, blue goes this way. It says calculate the slope of the red line. So I will let you do that quick, and then I will give you an answer. So if you want to pause this and do your calculation and then look at your answers compared to mine, your slope should be right there. On your next, after this, we can look at these. Which one has the smallest slope? Which one has the least amount of slope? And you can look, and you have a red line going this way, blue going this way, and green here. If you look at those lines, which one is the most horizontal, the least vertical, is going to be this green line here, has the least amount of slope. And wants to know the relative speeds of the objects represented by the 3 lines. So to find speed, remember we find the slope of the line. We found the red one. Red is, we said it was 4 meters per second was the slope. Green, we haven't done yet. But green starts here and goes up this way. So green's going to have a slope of 1. And blue, if we look at this one, is going to have a slope of 2 meters. 2 is going to be our slope there. So there's our different values. And then on this one, it says the slope of distance versus time graph is equal to the speed, which you've seen looking at those past couple examples. So slope, and this is really important that we remember, slope is equal to the speed. If you're moving at a constant speed, you will have a straight line. So constant speed here is straight line. Whether you're moving there, whether you're moving slower, you would have a straight line going off in this direction. You can also have a horizontal line. So this line here is also a constant speed because the speed would be 0. So notice the slope and how it compares. So this one is going up, this one's going up at a less of an angle, so much like my first yellow line. This one, notice the speed is changing and the slope of my line changes as well. So this one's showing you that if it stops, so a car is at a stop sign, it's got a speed of 0. Because its position doesn't change as time goes by, that means that my slope, so if the line of a resting car is a flat line, so between 2 and 3 seconds here, we notice this portion is flat, so that car would be stopped, whether it's at a stop line, a stop sign, a stop light, or just stopping for a person to walk across the street. This car is stopped for a second before it continues to move. And that is our changing velocity there. Thank you for your time and attention to these review questions. I would like you to answer questions 1 and 1, 2, and 3. 1, 2, 3, and 4. You can answer these first 4 questions and report these to me tomorrow. Thank you for your time and attention today, and I look forward to seeing you again next time.